Hello everyone, I welcome you all to Binju's Education. And today's topic of discussion is data sufficiency. And today we are discussing the fourth video on inequalities. Okay, so we are already done with three videos, which means we are done with 15 questions. So if you're watching this video for the first time on data sufficiency inequalities, then I would suggest you to have a look at the other three videos also. Okay, because we have discussed like a couple of basic questions. In this video we're gonna go a little bit higher than whatever we have done in the previous three videos. Okay, all right then, so we will follow the same method that we have been doing in the previous videos. I'm going to show you a question on a screen. You'll see that question, you're going to pause the video, you're going to try that question yourself, and then you're going to move on further. Okay, all right, so let's move on to question number one. Pause the video and try this question, please. Okay, so it says that is x plus y greater than 0? This is the question asked. And the first statement says that x minus y is greater than 0. Now, if x minus y is greater than 0, so there are like a lot of possibilities which can happen. For example, I can have x is equal to 1, I can have y is equal to minus 2, I can have x is equal to 5, I can have y is equal to 4, or let's suppose I can have x is equal to minus 3, I can have y is equal to, for example, minus 4 also. Okay. Now, in all the three cases, we have x minus y greater than 0. But what about x plus y? In the first case, you will have x plus y as 1 minus 2, which is equal to minus 1. In the second case, you will have 5 plus 4, which is equal to 9. In the third case, you will have minus 3 minus 4, which is equal to minus 7. So if x minus y is greater than 0, is it necessary for x plus y to be greater than 0? The answer is no. The answer is no. It's not necessary. It may be, it may not be. That actually depends upon the value. Do we have the values of x and y? No, we don't have that. So if I write D, A, B, C, E, so you can say that A goes out, D goes out. That is statement 1 alone is not sufficient, which means option D, which stands for both statements individually are sufficient, is also out. Now, let's move on to statement number 2. Statement number 2 says that x square minus y square is greater than 0. X square minus y square is greater than 0, which we can also rewrite as x square is greater than y square, which means we can say that mod of x is greater than mod of y. The mod value of x is greater than mod value of y. So for example, we can have x is equal to 5. We can have y is equal to 4. We can also have x is equal to minus 5 and y is equal to 4. Both of them satisfies. In the first case, the value of x plus y, in the first case, the value of x plus y is equal to 9. In the second case, the value of x plus y is equal to minus 1. So do we have a definite conclusion that x plus y is greater than 0? No. X plus y can be greater than 0, but x plus y can be less than 0 also. So again, we don't have a definite conclusion, which means statement 2 alone also doesn't satisfy. Now what if we combine both of them, because that's the only option left with us. Now for the second part, x square minus y square greater than 0, I can use the algebraic identity and I can rewrite this as x plus y into x minus y is greater than 0. A square minus b square is a plus b into a minus b. Now from statement number 1, we have x minus y as positive. That is x minus y is positive. Now if product of two numbers is positive, one of them being positive, can I say the other one has to be positive? What I mean to say is, for the sake of consideration, let's take x plus y to be a and let's take x minus y to be b. So A into B is greater than 0. It's given that B is positive. Can I say in that case A has to be positive? Can I say A has to be positive? Which means X plus Y has to be positive. So do we have a definite conclusion using both these statements? Yes, we do have a definite conclusion when we'll use both the statements. Hence our answer is option number C. Hence our answer is option number C. Alright, let's move on to question number 2. Pause the video and try this question please. Okay, let's see what we can do with this one. It says that R is not equal to 0. That means R can be positive. R can be negative also. R is not equal to 0. Is R square by mod R less than 1? So R square by mod R less than 1. Okay. Now let's first decode this. Let's try to understand this. First of all, what is meant by R square by mod R? Now, if you talk about mod of R, the value of mod of R is always positive. And interestingly, the value of R square is also positive. The value of mod of R is always positive. Value of R square is also positive. So first of all, this is a case of positive divided by positive. This is first of all a case of positive number divided by positive. Okay. So this value cannot be negative. So you want this value to be less than 1, which means technically we want the value of R square divided by mod of R to be between 0 and 1. We want the value of R square divided by mod of R to be between 0 and 1. Right? So let's see what we can do. So this will basically happen only in two cases. One is when the value of R is between 0 and 1. And another is when the value of R is between minus 1 and 0. Because whenever you have the value between 0 and 1, then higher the power, lesser the value. Whenever you have a value of R between, whenever you have a value of a variable between 0 and 1, then higher the power, lesser the value. Now, this is effectively not true for the negative numbers, but the point here is that you have a mod of R. So that negative actually has no meaning. We have a mod of R. So this negative basically has no meaning. So whether you have a number between 0 and 1, whether you have a number between minus 1 and 0, both will basically behave as the same way. For example, if I do half square, this is going to give me 1 by 4. And if you're going to divide this by 1 by 2, which is basically half, so this is R square and this is R. So if you're going to divide these two, you'll get a value which is less than 1. Similarly, if you take R to be like minus half, so again when you'll do minus half square, let me put a mod here, I forgot that. This is again 1 by 4. And mod of R is basically like mod of minus half. This is again equal to half. When you'll divide this, you'll again get a value which is less than 1. Okay, so so R is not equal to 0 is R square by mod R less than 1. So we have figured this out that for R square divided by mod R less than 1, it has to be between 0 and 1. That's the only possible way out, because R square and mod of R are both positive. Okay, so let's see what all do we have from the statements. Statement number 1 says that the value of R is greater than minus 1. Now if the value of R is greater than minus 1, it can be anything greater than minus 1. For example, R can be minus half, it can be plus half, it can be 2, it can be 4, and so on and so forth. It can be any value. Now, if the value lies between minus 1 and 1, excluding 0, because r cannot be equal to 0, if the value of r lies between minus 1 and 1, in that case, if the value of r lies between minus 1 and 1, r is not equal to 0, then r square by mod of r will always be less than 1. Because use the same principle that we discussed here, the higher the power, lesser the value. But if the value of r is greater than 1, for example, it is 2, 4, 6, 7, 9, 10, in that case, r square by mod of r will become greater than 1. For example, if we take example of 4, then 4 square is 16. 16 divided by mod of 4 is again 4. That is not less than 1, that is greater than 1. So simply saying that r is greater than minus 1 will not help us. If we write D, A, B, C, E, A goes out, D goes out. Second statement is R is less than 1. Now less than 1, it can be anything. Like for example, it can be half, it can be minus half, it can be minus 4, it can be minus 8, it can be minus 12. So till the time the value of R is between minus 1 and 1, we will get the required condition. That is r square divided by mod of r is less than 1. But what if r is like minus 8? If r is minus 8, then r square is 64 and mod of r is 4. Sorry, mod of r is 8. So 64 by 8 is equal to it. That is not less than 1. So again we are getting both the conditions. That is, the ratio of r square by mod of r can be less than 1. It can be greater than 1 also. So statement 2 alone again does not satisfy. But what if we combine both these statements? If we combine both these statements, then we'll get the result that the value of r is between minus 1 and 1. The value of r is between minus 1 and 1, and if you keep any value of r between minus 1 and 1, then r square divided by mod of r will always be less than 1. Because again, higher the power, lesser the value. Higher the power, lesser the value. Okay. So you can again say that your answer is simply option number C. Okay. Let's move on to question number 3 now. Pause the video and try this question, please. All right, let's try this question now. So the question is p square q greater than pq square? So is p square q greater than pq square? Let's first solve this. Let's try to simplify this. So we have p square q greater than pq square. This is the question. So I can write p square q minus pq square is greater than 0. I have subtracted pq square on both the sides. Then I can take pq common. P minus q greater than 0. This is the actual question. So the actual question is p into q whole multiplied by p minus q greater than 0? This is the actual question. Now first let's figure out what are the possibilities for the multiplication of these two expressions to be greater than 0. So we can have one thing, that is pq greater than 0, p minus q greater than 0, and we can have another thing possible, that is pq is less than 0 and p minus q is also less than 0. Okay. All right. Now statement number 1. First statement says that PQ is less than 0. Okay. Now if PQ is less than 0, can we comment anything regarding the value of P minus Q? Because if PQ is less than 0, I also need P minus Q to be less than 0. Right? Then only I can say that, then only basically I can conclude a result regarding the question which has been asked. That is p square q greater than pq square, right? Because I require a conclusive result. So if pq is less than 0, it may happen that p is positive, q is negative, or it may happen that p is negative and q is positive. If I take the first case when p is positive and q is negative, in that case p minus q will basically become positive. If I take the other case, in that case it will become negative. So I don't even have the value of p and q. I don't even have the signs of p and q, so I can't comment anything regarding p minus q. It can be anything. It can be positive, it can be negative. So do we have a definite conclusion regarding the signs of p minus q? No. Do we have a definite conclusion regarding the signs of p minus q? No, we don't have that. So can we conclude anything regarding the multiplication of pq into p minus q? No, we can't do that. Okay. So if we draw D, A, B, C, E, A goes out, D goes out. Okay, second statement. Second statement says that P is less than 0. Now if P is less than 0, do we know anything regarding Q? No. Q can be positive, Q can be negative also. There will be like a lot of possibilities. So simply by saying P is less than 0 will not help us at all. So B effectively goes out. Now what if we combine both of them? What if we combine both of them? Now it says that P is less than 0, and from the first one we have PQ less than 0. So we have PQ less than 0, we have P less than 0, which basically means that Q has to be greater than 0. Which means that Q has to be greater than 0, which means P is negative and Q is positive. Now let's use these signs in the actual expression. So if we talk about PQ, this will become negative because this is positive into negative. And if we talk about P minus Q, this will become negative minus positive, which in turn overall is negative. So we have a negative quantity PQ whole multiplied by another negative quantity, which is P minus Q, and this entire thing is greater than 0, or effectively this is a positive. So do we have a definite conclusion? Yes, we do have a definite conclusion when we combine both these statements. Hence our answer is option number C. Hence our answer is option number C. Alright guys, let's move on to the next question. Pause the video and try this question please. Okay, let's see what we can do with this one. X and Y are non-zero integers. Okay, non-zero and integers. Both the informations are really important. Is x to the power minus 1 plus y to the power minus 1 whole to the power minus 1 greater than x to the power minus 1 y to the power minus 1 whole to the power minus 1. Okay, so this is like 1 over x plus 1 over y whole to the power minus 1 greater than 1 over x into y whole to the power minus 1. So this is x plus y divided by xy whole to the power minus 1 greater than 1 over xy whole to the power minus 1. So this will be xy divided by x plus y greater than xy. This is the actual question that we have to answer. So is xy divided by x plus y greater than xy? This is the question that has been asked to us. Now let's see what we can do with the two statements. Now before we actually move on to the statements, Okay, let's start with the statements because I was actually thinking of simplifying this further but I just realized that it's gonna make this expression a bit more complicated. Let's keep it as it is. So the first statement says that x is equal to 2y. Okay, if x is equal to 2y, let's replace x by 2y. So this becomes 2y square divided by 3y is greater than 2y square. Now y is a non-zero integer. Y is a non-zero integer, which means y square has to be positive. Which means y square has to be positive. Which means I can divide both sides by 2y square, because whenever you divide by a positive quantity, the sign of inequality does not change. We will have 1 by 3y is greater than 1. We will have 1 by 3y greater than 1. Okay. So if y is a non-zero integer, if y is a non-zero integer, so the values of y, let's first talk about the positive part. The values of y will be like 1, 2, 3, 4, 5, and so on and so forth. If the values of y are like 1, 2, 3, 4, 5, so on and so forth, can I say one thing is for sure, that 1 by 3y will definitely be less than 1? Because when you'll replace y by 1, it will become 1 by 3. When you'll replace y by 2, it will become 1 by 6, then 1 by 9, then 1 by 12, then 1 by 15, and so on and so forth. So if the value of y is like 1, 2, 3, 4, 5, 6, 1 by 3y will always be less than 1. And what if we take the value of y, what if we take the value of y to be minus 1, minus 2, minus 3, minus 4, and so on and so forth. So this will basically become 1 divided by a negative number. So overall this will become a negative number, which will definitely be less than 1. Which will definitely be less than 1 again. So in both the scenarios, whether you take y to be a positive integer, whether you take y to be a negative integer, in both the cases, I have a short result that 1 by 3y is less than 1 by 3y is less than 1. So do we have a conclusive result? Yes, we do have a conclusive result. We have D, A, B, C, E. B goes out, C goes out, E goes out. Which means if the second statement individually is also sufficient, so we'll go with D. Otherwise, we'll simply go with A. That's it. Okay. Now let's see the second statement now. Okay. Now the second statement says that x plus y is greater than 0. Which means I have xy divided by a positive quantity greater than xy. Now, even though if x plus y is greater than 0, do we know the individual values of xy? Do we know the individual values of xy? No, we don't know that. It may happen that x and y are both positive. Let's suppose x is 3, y is 1. It may also happen that x is 3 and y is minus 1. In both the cases, like x plus y is positive. So if I plug in the first case, I will have 3 divided by 2 greater than 3. Is this true? No. If I put the second case, so this I'm gonna have minus 3 divided by 2 greater than minus 3. Is this true? Yes, this is true. Now, even though I know the value that x plus y is greater than 0, do I know the individual values of x and y? No, I don't know that. Do I know that whether their multiplication will be positive or negative? No, I don't know that also. So, am I going to get any conclusive result from this? No, I will not be getting any conclusive result from this. So D goes out. Hence, my answer is simply option number. Alright, then let's move on to the last question of this video now. So pause the video and try this question, please. Okay, let's see what we can do with this one. So is 3 to the power p greater than 2 to the power q? is 3 to the power p greater than 2 to the power q. Statement 1 says that q is equal to 2p. So I will have 3 to the power p and 2 to the power q. In place of q, you put 2p. So 3 to the power p, 2 to the power 2p. 3 to the power p, 2 square to the power p, 3 to the power p, and this will be 4 to the power. Now, which of them is greater, 3 to the power p or 4 to the power p? Don't write 4 to the power p is greater. Don't write 4 to the power p is greater. If p is positive, then 3 to the power p will be less than 4 to the power p. If p is equal to 0, 3 to the power p will be equal to 4 to the power p. If p is negative, then 3 to the power p will be greater than 4. For example, if you take p to be 1, then 3 will be less than 4. In this case, 1 is equal to 1. If you take p to be minus 1, then 1 by 3 is greater than 1. So do we have a conclusive result? No, we don't have a conclusive result. So D, A, B, C, E, A goes out, D goes out. Second statement says that Q is greater than 0. Simply saying Q is greater than 0, do you know anything about P? No, you don't know that. What if P is like 0? What if P is negative? What if P is positive? All three possibilities are there. Again, if P is greater than 0, then 3 to the power P will be greater than 2 to the power. If P is equal to 0, in that case 2 to the power Q will be greater. If P is negative, then again 2 to the power Q will be greater. Do you have a conclusive result? No. B goes out. So what if we combine both of them? What if we combine both of them? So if Q is positive, Q is actually equal to 2P. If Q is positive, can I say P has to be positive? P has to be positive. There is actually no other value possible for P. Which means, can I say this is the only applicable case that we have? So do we have a conclusive relationship between the two things? Yes, we do have. So our answer is option number C. Okay, just one small twist. Let me make that in the question. Instead of this second statement, let's suppose if the second statement was Q is not negative. What would have been your answer in that case? Let me know that in the comment box. Okay. Alright guys, thank you so much. So these are the again the 5 questions from the inequality topics of data sufficiency. I hope you have enjoyed the videos. If you have any questions, any concerns, any queries, do let us know in the comment box. You can also drop us a mail. You can also WhatsApp us. And if in case you haven't subscribed the channel yet, please do that for more videos and exam related content on GMAT, GRE, and NCT. If you're looking for personalized classes, you can always connect with us. Guys, thank you so much. Keep watching and keep learning.